Okay, so you have your 3-6 notes in front of you. Again, this is the last section we're going to do that you will be quizzed on. So I won't be here, but in January when you guys come back, there's one more section in chapter 3 or module 3 that we will be doing, but you won't be quizzed over it, so I'm not too worried about it. So this is the last section, and it's about the quadratic formula. And the quadratic formula is cool because there are certain types of equations. So you guys probably made the connection, or hopefully made the connection, that when we're completing the square, that's on some equations that just can't be factored. If you try and look for two factors that multiply to your last number, add to the middle number, you can't find those if it happens to be like a square root of something, right? So there are limitations to factoring, and there are actually limitations to completing the square too. Not that completing the square always works. It just gets really hard if you have an A term or if your B is odd, because then you can't divide by 2. So this quadratic formula works 100% of the time. We could just give you the quadratic formula and you could solve everything. Yeah. Yes, please. So I'm not going to show you guys this because it is kind of crazy magic. But basically, do you remember this general form ax squared plus bx plus c? Yeah. This is our quadratic form. How the quadratic formula came about, and maybe someday I'll show you this because it's some cool math magic, is that somebody, and I can't remember who, completed the square on this general equation with letters, and the quadratic formula pops out. So that's what it happens to be, and I will show you some other time. But this is the quadratic formula. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I think you have to have it memorized. Chances are. So this is something to memorize. We're going to write it many times. And I'm sorry, I guess I should give you the definition. To solve any quadratic equation, you can use the quadratic formula. Quadratic formula. So it works for every single quadratic function we will see. Emily, Stephen, can you guys put away your laptops for me? Thank you, baby. I like the quadratic formula, but it is a plug and chug game, and it's all about simplifying. So I'm going to do a total of 6 examples today. I'm going to do 4 with real roots, meaning there's not going to be any complex parts, but they get ugly. And then I'll do 2 that have complex parts that also get ugly. Okay, so our first thing to do here is to remember this general form. We'll need to know what our A, our B, and our C is in order to plug it into this equation. So I always start by naming my A, B, and C. So what is my A term here? What's in front of my x squared? 1. What's in front of my x? 8. So that's my B. And what's in front of my nothing? My C. What's my C? 15. I'm going to write the quadratic formula again, just right here, so we can kind of see it on camera still when I move this up. But it is a whole fraction on top, and on top of this fraction is negative b plus or minus, because there's 2 solutions, the square root of b squared minus 4ac all over 2a. I will try and color code a little bit here. I'm going to start with just my plug-in step. So I'm going to take this equation of x equals, and then we're going to start plugging things in. So I'm going to do negative, and then my b term, which in this case is 8, plus or minus the square root of, and then I am going to put this in parentheses because when you type this into your calculator, you'll want to make sure if it's a negative b that it doesn't give you a negative square. So it's 8 squared b squared minus 4 times my a term, which in this case is 1, times my c term, which is 15, all divided by 2 times my a term, which in this case is 1. I would say on a quiz, that first plug-in step is 1 point. Okay, can you just plug this stuff in? If anything else happens afterwards, oh well. But that first step is sort of, I mean, that's 1 point. Show me that you know what to plug in where. So now I'll start simplifying. So I have -8 plus or minus the square root of what's 8 squared? 64. Minus, and then this will be 4 times 1 times 15, really 4 times 15, which is 60, all over just 2, right? Now this is how I'm always going to break it up in the notes and in my work. But for the record, you could take your calculator and you could take this inside part and just type it in all how you see it. It'd be, let's see here, parenthesis 8 squared minus 4 times 1 times 15. If you wanted to type it in that way, it's going to give you 4. And we see 64 minus 60 is 4. So you're welcome to type it in like that as well. What is the square root of 4? 2. So we have -8 plus or minus 2 over 2. At this point, remember last time when we were completing the square, I said if you have a whole number here and a whole number here, you should split them into 2 distinct answers, right? You don't have to do that if it's a square root or if there's an I. But in this case, these are all numbers that we know how to deal with in our heads, hopefully. So we can split this off into 2 separate solutions. We can say that this is the same as x equals -8 plus 2 over 2. X equals -8 minus 2 over 2. Just as a reminder about order of operations, remember when you have like 2 things in the top of a fraction, that's like an implied parenthesis. So you should do the top of the fraction first. So -8 plus 2 is -6 over 2. -8 minus 2 is -10 over 2. And so this would be that you have x equals -3. You have x equals -5. Yes?
Don't you just simplify the -8 of plus or minus 2 over 2?
Right up here?
Yeah.
Yes, you can. So Molly's question is, can you simplify right here? You absolutely can. You have to be careful of doing that. That's why I didn't show you that way. In order to simplify everything, it has to be that all of these parts simplify. And you'll see a couple examples where there's a square root. You can't simplify from inside a square root. Okay, so it's just something to watch out for. But yes, you could simplify. You could divide everything by 2 here so that you have -4 plus or minus 1. And then just go from there. Just as a quick reminder, so on Go Formative, you just list this -3, -5, or -5, 3. You can always check your answers, though. It was harder to check our answers when we have square roots because those are decimals. But you can always check your answer by typing in the original function, which in this case was x squared plus 8x plus 15. Look at your graph, see where it hits the x-axis. Sure enough, it hits the x-axis at -3 and -5. Okay, always can check your answer that way. If you have square roots, they're decimals then, so it's harder to see, but you can kind of ballpark it at least. Let's see another one. This one's still going to be a nice, neat one. So I will always start by listing my A, B, and C. So my A here is what? What's my first term? 1. My B, what is my B? -18. And what's my C? 72. Good. I will continue to try and color code. So we'll have x equals negative, and then I plug in my -18. Notice I have a double negative there. We will clean that up in a second. Plus or minus the square root of, and then it's important that I put the -18 here in parentheses. -4 times my A, which is 1, times my C, which is 72. All over 2 times my A, which is 1. Right there, 1 point on a quiz, just to have it plugged in correctly. So a negative makes what? Positive. And then here's where you have to be careful. Remember, your calculator will lie to you sometimes. If you just type in -18 squared, it's going to say it's -324. What is it actually? +324. So that's why I always put the parentheses, just so that I know that I'm not going to make that mistake. So this is positive 324 minus 4 times 72 would be 288 all over 2. Again, you could type in this whole line into your calculator, though. You do negative 18, make sure it's in parentheses. The square is outside of the parentheses. Minus 4 times 72, and that'll give me 36. 324 minus 288 also gives me 36. So 18 plus or minus the square root of 36 over 2. What's the square root of 36? Okay. So at this point, again, Molly's correct. We could technically reduce all of these by 2. Or if you would like to be safe and just have a routine that always will work, split these off. You can make this 18 plus 6 over 2, 18 minus 6 over 2, 18 plus 6, because my brain doesn't work this morning, is 24 over 2. This is 12 over 2. So you end up with x equals 12 and x equals 6. Again, those are numbers you could check on your calculator. So it works great for whole numbers. Actually, more simplification when we have whole numbers there. Let's see some uglier ones. Any questions so far before I go on? So these were nice, neat answers. Technically, we could have factored those. Yeah.
For the 18, like, will we still get it right if we add the negative?
If you just put a positive 18 right away, yes, absolutely. Yeah. All right, so part C. Now we have one where A is not 1, which doesn't really change anything too much. So I have my A is 3, my B is -5, my C is -1. I think it's really important just to list those to start. I also, again, you guys have to have this memorized. So I always like to rewrite on the top of whatever page I'm working on. I like to rewrite the quadratic formula. So it's one whole fraction, negative b plus or minus the square root of b squared minus 4ac all over 2a. So for 1 point on a test, I would start by just plugging these in. And Lindsay's question was, if I didn't put -5, would I still get a point? If you just put +5, yes. You can just do the opposite of b if you'd like. I'm always going to put the negative just because I guess that's how my brain works. -5 plus or minus the square root of -5 in parentheses squared minus 4 times my a, which in this case is 3, times my c, which is -1. Oops, I did that in the wrong color. I'm trying to color code here. Then I will do all divided by 2a, so 2 times 3. All right, 1 point on a quiz. Then I start typing stuff in. So I have 5 plus or minus the square root of -5 squared is a positive 25. -4 times 3 is -12 times a -1 would actually be a positive 12. So this becomes, instead of 25 minus 12, it becomes 25 plus 12. All over 6. 25 plus 12, it's so close to a perfect square, but it's not. It's the square root of 37 all over 6. Is there anything I can do to simplify here? Not a darn thing. Those are actually really the nice ones. And probably you'll have at least one quadratic formula one on your quiz where like you just plug everything in, you simplify that square root, and then that's it. So it's a very ugly answer in terms of like what it looks like. It is some decimal. But that's your answer. You can put it in to go formative like that, or you can put it in as 5 plus square root of 37 over 6, 5 minus square root of 37 over 6. Reminder that it is actually a number. Like if you typed this in, the plus one is that decimal. The minus one is that decimal. That just means that this parabola crosses the x-axis at like 1.847. and negative 0.1805, I guess, if we're rounding. So it's still, it's like an actual number. It's just not something you could factor to. So ugly, but at least less work for us. I'm going to do a couple more still because some people like to see. I'm always surprised you guys do better with quadratic or with the completing the square than quadratic formula, and I'm not sure why. See if you guys can buck that trend. So my A is 1, my B is 4, and my C is negative 17. I will take a step to do all my substitutions. So I'll have negative B, so negative 4, over, not over, I mean it is over, but plus or minus square root, parenthesis, B squared, so 4 squared, minus 4 times 1 times negative 17, all over 2 times my A, which is 1. And I guess back to Lindsay's question, like if you were to simplify as you're plugging in, like a lot of you can do 4 squared in your head. If you put 16 here right away, I would still give you 1 point on the quiz for having that correct initial substitution. So it'd be negative 4 plus or minus the square root of 16. And then 4 times 1 times negative 17 is again going to be a positive. So I'm going to end up with a plus in the middle there. So you can think of it as negative 4 times 1 times negative 17. And I'll end up with a positive 68 all over 2. So I'll have negative 4 plus or minus the square root of 84 over 2. Now here's where I want to caution you. Back to Molly's question of can I simplify from here? These are all even, right? Okay, you cannot simplify from inside of a square root. It's so tempting to do it, but remember, square roots are jail. You cannot do anything unless you bust that number out. So we can pull something out of 60 or 84. It is divisible by 4. So before you do any simplifications, you need to divide or simplify this square root. So make it 21 and 4. 21 does not have any pairs in it, right? It'd be 3 and 7. But 4 has a pair of 2's in it. I've been very impressed. A lot of you are really quick with these now, which is awesome. So this would simplify as negative 4 plus or minus 2 square root of 21 all over 2. At this point, you can now simplify. So what has to happen in order for you to simplify is that you have to be able to simplify here, here, not in a square root, and on the bottom. It can't just be that you simplify here and here, or from inside the square root. It has to be all 3 spots. So I can divide by 2, divide by 2, divide by 2, which would leave me with negative 4 plus or minus. There would be a 1 here, but GoFormative doesn't want to see that. So I'm just going to put square root of 21. And then again, it would be over 1, but I don't need that. Oh, I'm sorry, negative 2. Thank you. Because 4 divided by 2 is 2, not 4. So this would be how you would enter your answer into GoFormative without the x equals. So hopefully you guys can see it's the simplification part that's probably the hardest. So think of these as they're probably going to be worth about 3 points. 1 point for that initial plug-in, and then 2 points for everything else. I'm going to do one more because they kind of look the same anyways. Let's do example A, 2A, and I'll do 2B tomorrow just as a refresher. So I just want to show you one with complex roots, and it does have more simplification, which is good for us. Again, I'm going to write the quadratic formula right here, so that we have it in lots and lots of spots, and we can start memorizing it. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. Sometimes one of the mistakes I see with students memorizing this is that they'll put the negative b out front, and then they'll the divided by 2a is only this part. It's this whole thing divided by 2a. So part A here, my A is 5. my B is negative 10, and my C is 24. So I'll have x equals negative 10. I'm just going to scoot this up. Plus or minus the square root of my b squared, so I'm going to put it in parentheses, or you could just make it positive if you wanted to, but negative 10 squared minus 4 times my a, which is 5, times my c, which is 24, all over 2 times my a, which is 5. One point. All right. So I'd have a positive 10 plus or minus the square root of what's negative 10 squared? 100. And then this would end up being minus 4 times 5 is 20 times 24 ends up being 480. So do you guys see what's going to happen inside that square root? Yeah, you're going to have a negative. This is where you get those complex roots. It's nothing too crazy from what we've been doing, but we're going to have an I floating around. So I'll have 10 plus or minus the square root of negative 380 all over 10. 380 is not a perfect square. However, it is divisible by 4. It's not divisible by anything else. 380.
I did 38, 10.
That would work. But if you're thinking about perfect squares, it's almost easier just to do 4 and 95. You're right, 38 and 10 would work. You'll get the 4 out anyways then. Or you'll get 2 2s, 2 sets of 2s. 95 doesn't have any pairs in it. It has lots of things it's divisible by, but not pairs. So if you do 38 and 10, you should still end up with 10 plus or minus 2i, because we take out that negative, square root of 95, all over 10. What can I reduce by here? 2. It's tempting to want to reduce by like the 5 or something, right? But again, this is jail. Nothing comes out of jail. So we're going to reduce everything by 2 because we can't reduce everything by 10 because this 2 right here is not divisible by 10. So this is just some fraction rules that we have to remember. So you end up with this rather ugly fraction, x equals 5 plus or minus I times the square root of 95 all over 5. Again, it's tempting to say, oh, but 5 is divisible by 5. Just make that a 1. It has to be in all 3 spots. So that is the final ugly answer. What questions do we have about quadratic formula? Pretty straightforward.